let's look at the normal form of equation of the plane. So as you know, normal basically means perpendicular to, right? So we have origin, let's say this is a point N and this is a point P, and this is the perpendicular distance from the origin, okay? And let's say this is a point P represented by this vector, okay? Now the length of the perpendicular from the origin to the plane equal to, let's say this is capital P, this is small case p. Let's say n cap is the unit vector along the perpendicular, that is on, okay? On can be written as the distance, that is the magnitude, times the unit vector, so Pn cap. So remember, this is nothing but magnitude times magnitude and the unit direction, unit vector. Now P is any point on the plane, so the position vector of P is, let's say, R, vector R. By the way, in the diagram now On is P n cap. Now On we have seen, OP we have seen. Now NP would be what? NP would be OP minus ON, which can be written as vector R minus P dot n cap. Now remember, NP lies on the plane. ON is normal to the plane, which means angle ONP is equal to 90 degree. This implies that NP dot ON is equal to 0. Dot product of perpendicular vectors is 0. Okay, now NP is what? R minus P dot n cap. ON is what? ON is Pn cap. Pn cap equal to 0. Now Rpn minus P square n cap, when we multiply it becomes 1 equal to 0. Now P times equal to 0, and which means, now here remember, the distance cannot be 0. That means it should not be on the origin. So this is the normal form of the plane. Now let's look at the Cartesian form. Let's say P is represented by x, y and z, and L, M, N are the direction cosines of the perpendicular ON. So which means now we can write n cap as Li plus Mj plus Nk. This is the unit vector along n ON. Now OP, which is R, is equal to Xi plus Yj plus Zk. Now if we look at the diagram, remember we know the equation, normal form, n cap equal to P. We just derived it. Okay, so using that, let's substitute. So Xi plus Yj plus Zk dot n cap. N cap is Li plus Mj plus Nk is equal to P. Now this is a dot product, so multiply Lx, I times I is 1, I times j will be 0, I times k will be 0, so we don't have to bother about it. Now my plus nz is equal to p. Now remember, L square plus m square plus n square would be 1. So this is the normal form of the equation ax plus by plus c z plus d equal to 0, the equation of the plane. Okay, now let's look at some interesting aspects. Now we have the equation of the plane ax plus by plus cz plus d equal to 0. This can be written as ax plus by plus cz equal to minus d. Now here a, b, c are the direction ratios of any line perpendicular to the plane. So let's do one thing. Now let's divide this entire thing by square root of a square plus b square plus c square. So a by square root of a square plus b square plus c square, x plus b by square root of a square plus b square plus c square, y plus c divided by square root of a square plus b square plus c square, z is equal to minus d by square root of a square plus b square plus c square. Let the coefficients of x, y and z be L, M and N. Then L square is equal to a square by a square plus b square plus c square. M square is equal to b square by a square plus b square plus c square. N square is equal to c square by a square plus b square plus c square. Which means if we add them up, we get 1. LCM will be a square plus b square plus c square. Common LCM, same, all of them. So it's just a question of adding up the numerators. The above equation, this one, becomes what? Lx plus my plus nz is equal to, now here, minus d by square root of a square plus b square plus c square is p, that is the perpendicular distance from origin. Okay, we can look at it like this, or we can also look at it like this. Now let's say we have two planes, a1x plus b1y plus c1z plus d1 is equal to 0, a2x plus b2y plus c2z plus d2 equal to 0. Let's say this is plane 1 and plane 2. Now the direction ratios of the normal to the plane 1, direction ratios of the normal to the plane 2 are a2, b2, c2. Let's say this is a1, b1, c1. Now if the plane 1 is parallel to plane 2, it is understood that the normals to the planes 1 and 2 will also be parallel. That means a1, b1 and c1 are proportional to a2, b2 and c2 respectively. So this again implies that a2 by a1 is equal to b2 by b1 equal to C2 by C1. They are proportional. Now let's say that these ratios are equal to lambda. Now if we take them, each one of them individually, then A2 would be equal to A1 lambda. B2 would be equal to B1 lambda. C2 would be equal to C1 lambda. Now we know that plane 1 is A1x plus B1y plus C1z plus D1 equal to 0. Now what we are going to do is we are going to write the plane 2, which is A2x plus B2y plus C2z plus D2 equal to 0. Now we want to write this in terms of A1, B1, C1. So A2 can be substituted with A1 lambda x plus B1 lambda y plus C1 lambda z plus D2 equal to 0. Right? Now we want to remove these lambdas. So what do? Divide this entire thing by lambda. So we will be left with A1x plus B1y plus C1z plus D2 by lambda equal to 0. This D2 by lambda, they are constants, right? So we can as well name it as a separate, using a separate alphabet. Yes. So let us say this is D equal to D2 by lambda. So our equation would become A1x plus B1y plus C1z plus D equal to 0. Now the point is what? The point of this is that you have a plane. If you want to create another plane which is parallel to it, the only thing you have to do is find a multiple of D. Given a plane, to get a parallel plane, just use a multiple of D, which is the constant. Now this multiple factor can be fraction or integer, or if we put it in another way, if two planes have common direction ratios and the constant D is a multiple of the other, then they are parallel. And finally, let's say this is the position vector of any point on the plane ax plus by plus cz plus d equal to 0 relative to origin. So that means this can be written as xi plus yj plus zk and on equal to n. Vector n can be written as ai plus bj plus ck. Now remember, this is not the unit vector, this is the normal vector. So the equation of the plane can be written as ai cap plus bj cap plus ck cap dot xi cap plus yj cap plus zk cap plus d equal to 0. Now how did this come suddenly? If you multiply it, what do you get? If you do the dot product, ax, I times I is 1, So ax plus by plus cz plus d equal to 0. That means they are equivalent. Now, what is this? This is normal vector dot the position vector of a point on the plane plus d equal to 0 to minus d. Now, if we want to get back in terms of the unit vector, not in terms of on, but its unit vector, then what do? We divide this by magnitude of the unit vector. So magnitude will get cancelled and only direction will be left. So we have to divide it this side also by. Now this is the projection of the distance from the point to the origin onto ON. So here n cap r vector is equal to, let's say this is P, where P is nothing but the absolute value of d by magnitude of, because this minus is there. So again we come back to the same. So you need to understand the difference between n cap and n vector. This is important. Don't miss this when you are reading any text. So I think you got the idea. Go through it a few times to really understand it. Think enough for today. Bye for